Yeah, everybody's got that benefit. All right, thanks. So we'll get things moving along. We're going to have a shorter session now. The ready-to-market presentation by Travis Parke won't be taking place. He had the last-minute schedule change, was not able to join us. So we'll start first with Ali Chertack, who is from the American Chemistry Council, and her presentation today is going to be on a focus on advanced recycling and mass balance, something important to all our projects. So, Ali?
Thank you very much. Good morning, everyone. So as mentioned, my name is Ali Chertack. Sorry, just trying to make sure I can see my own slides. I'm good, but I'm not memorize every slide good. So as mentioned, I'm with the American Chemistry Council, and I will be presenting on circularity with a focus on advanced recycling and mass balance. Great, okay. So for those of you who may not be familiar, the American Chemistry Council, or ACC, is a trade association in the plastics and chemical industry. So I wanted to provide a quick snapshot of our membership in the plastics division where I focus my work. So as you'll see here, we have our plastics producers or material suppliers, a lot of familiar faces on this screen. And then we also have our value chain members. So these are folks that are throughout the supply chain and may include converters or processors, as well as some recyclers, mechanical and advanced recycling. So first of all, what does ACC do? So we are focused on accelerating circularity, right? We want to create and foster a circular economy for plastics because it's a critical part of the solution to ending plastic pollution in the environment. So a couple things to note here. Four really important aspects of circularity and accelerating circularity. So plastic circularity extends beyond recycling. It's really important to note that it is so much more than just recycling. A circular economy offers a whole host of benefits, including preserving resources and reducing pollution, right? We're trying to create a loop rather than that linear economy that we've been utilizing for so many years. An all-encompassing strategy begins with designing for circularity. You have to start with designing with circularity in mind, and then reuse and recycling, right? And then one of our key focuses at ACC, enabling a circular economy through policy and regulation to increase access, improve current infrastructure, and encourage investments. All right, so I'll start with our circular economy goals at ACC. We established these around 2018 with the ultimate goal of 100% of US plastics packaging will be reused, recovered, or recycled by 2040, with the interim goal that 100% of plastics packaging in the US will be recyclable or recoverable in 2030. So I just want to note that we are currently in the process of reevaluating these goals to expand them to include other technologies and innovations that have come to fruition and been developed more since these were first established in 2018, right? Examples include expanding to include bioplastics, renewables, compostables, etc. So with that, you can't have a goal without tracking your progress. So in 2017, our economics department started tracking announced investments in the United States of mechanical and advanced recycling infrastructure. Right, so you may recall in 2017, the China sword policy went into effect, and this said that we would no longer be able to send our recyclables and our waste over to China. So we had to establish infrastructure in the United States for recycling domestically. So since 2017, there have been investments of nearly $11 billion in both mechanical and advanced facilities that could divert more than 16 billion pounds of waste from landfills. Just to note, these numbers come from publicly available announcements and media profiles and what have you. And so we are tracking this information to see what facilities are planned, under construction, and what are currently completed and in operation. So we're constantly updating these numbers so we can follow along with what the industry is doing and accomplishing. All right, so now I'm going to talk a little bit more about the data side, right? We at ACC are connecting the dots between data and action. We cannot really promote policy without data to support it one way or the other. So we have a whole host of reports that have either been conducted or are under development. So one of these is a report conducted by a professor at City College of New York. It was a literature review on about 14 different life cycle assessments on various advanced recycling technologies. It found that advanced recycling can reduce carbon dioxide emissions by more than 100% compared to alternative end-of-life processes. It could also reduce fossil energy by up to 97% compared to landfilling, and produce plastic and chemical products with a lower global warming potential compared to conventionally produced products, right? So a lot of potential positives from advanced recycling technologies. Right, another study conducted by Argonne National Labs alongside of our team focused on post-use plastic to polyethylene versus virgin polyethylene in a life cycle assessment through pyrolysis. So data was collected from 8 pyrolysis producers, 7 in the United States and 1 in Europe. This data was a combination of data from current facilities in operation, as well as some simulation data. So in the United States, currently polyethylene is produced with 6% naphtha and 94% gases. So the study looked at a whole host of different scenarios and considerations, including 5% pyrolysis substitution rate and a 20% substitution rate. So you're substituting 5% and 20% pyrolysis oil for that naphtha and some of those gases in those different scenarios. So the table to the right shows some of the maximum percent reductions for HDPE and LDPE in fossil energy consumption, greenhouse gas emissions, and water consumption for that 5% substitution rate for the nth plant. So again, between this and the other report I just mentioned, shows some really positive impacts and potential for advanced recycling technologies, right, that could decrease the environmental footprint of more circular plastics and products there. So if you want to read the full report, I'm happy to share it afterwards as well. So another study that we have in development, this is on contaminants. So we are conducting, again, this is a study by City College of New York. It is looking at an analysis of pyrolysis oil derived from post-use plastics. And just to mention, I say post-use plastics or PUP a couple times in this presentation. So it is a combination of post-consumer and post-industrial. So we are looking to identify contaminants, if any, and their levels in pyrolysis products and byproducts, right? There's a lot of uncertainty around what impurities and contaminants may remain based on the high temperatures of pyrolysis, but there's varying temperatures that are utilized, technology to technology, plant to plant. So we're looking to kind of refute some of the uncertainties or myths, right? To find out what is actually destroyed and what may remain. So again, final report aims to clarify what remains in different scenarios and reduce uncertainty. Because we cannot inform policy or support certain policy without findings and data to show one way or the other. Which leads us into SNRs and pyrolysis. So the EPA released a significant new use rule, or SNR, under Toxic Substances Control Act, or TSCA. You know, DC loves our acronyms. So this SNR was focused on chemical outputs from pyrolysis, right? The SNR proposed to address potential concerns that additives may be present in that PUP or post-use plastic after being processed via pyrolysis. So they're saying, there might be additives in the pyrolysis output products because it may be present in the post-use plastics, right, that we're collecting and processing. So current evidence, as I mentioned in the previous slide, shows high temperature processes may eliminate additives that are of a potential concern. But again, we are aiming to debunk those myths and determine what is true and not true. So one of our suggestions that we are working on in providing the EPA is a uniform testing method for incoming feedstock that would enable the identification of feedstock with certain additives. Because we again want to emphasize that we shouldn't have knee-jerk reactions to concerns. They should be decisions, regulations, et cetera, should be based on data and findings, scientific findings. All right, so shifting a little bit over to mass balance and chain of custody approaches. So for those of you who may or may not be familiar, chain of custody tracking approaches refers to tracking materials through a manufacturing or a process. And there's a couple of different forms of chain of custody approaches. So identity preservation, right, inputs originate from one source. An example of this is buying food from a single certified organic farm. Segregation means inputs with the same characteristics, but different sources. They're kept together and segregated from and separated from non-identical products. A great example of this is buying food from a trader that handles identically certified, let's say, organic certified supplies. Mass balance, which is what we're going to focus on, right, is inputs with certain characteristics can be commingled and mixed with other inputs that do not have those same characteristics. So if you're buying a percentage of supply from certified origin, fair trade coffee, chocolate, etc. So book and claim is another one. No physical connection between certified product and input materials. An example of this is buying carbon offset. So again, we're just going to focus on mass balance, but I wanted to provide some of the examples you may be familiar with. So I wanted to include this visual because it's a great way of showing how mass balance works, right? So this visual is from ISCC, which was one of the external certification bodies for mass balance, right? So on the left-hand side there, you have your different feedstocks going into the same manufacturing processes. You have fossil feedstocks, renewable feedstocks, chemically recycled or advanced recycled feedstocks, right? So you have a commingling, and then mass balance says you can track how much of the end product includes that chemically recycled feedstock versus the renewable feedstock, right? So it allows you to not have to use current infrastructure, not build new infrastructure, and be able to track what your recycled or renewable or circular feedstock is in the final product. Right, so again, independent and certification and mass balance are not something new. It's a well-established method used in a lot of different products, as mentioned, fair trade cocoa or coffee, to support sustainability statements. And third-party certification just ensures that level of credibility and transparency that confirms, yes, this, when you say there is 10% recycled feedstock or circular or renewable feedstock in my, let's say, plastic water bottle, it can be confirmed and credible by that third-party certification. So we really support, again, third-party certification to add that extra layer of don't just trust us, trust the certification. All right, then I also wanted to touch on a couple of the different studies and areas that we are also working on related to data before we switch into policy. So as you can tell, we are always very busy. We are never bored here at ACC. And some of the products we're working on are emissions. We had a report published and conducted in 2021 by Good Company Report comparing site-based emissions from pyrolysis to emissions from common manufacturing processes. Okay, findings showed that site-based emissions from pyrolysis were lower than common manufacturing, lower or about the same. So again, this is a study that would be beneficial to update and look at again and emphasize that pyrolysis is about in line with other manufacturing processes. Right, permitting. We published a permitting pathway fact sheet to show the extensive process and steps required to plan and permit a new advanced recycling facility. Standards. We're participating in several different standards that are under development, participating in the work groups, keeping our membership informed, right, related to mass balance and advanced recycling, to inform our members and also keep up with what is going on. It's really important, again, standardization, certification, so we like to be a part of the conversation there. Measurement. We have all these goals, but it's really important to collaborate with industry stakeholders and track progress against all sorts of our different goals. And then lastly, recycled content. We're in the process of developing language for producer or product level minimum recycled content requirements for plastics packaging and including methods for attribution. There's a lot of different approaches, interpretations, definitions that are out there. So we not only have to align our membership, but we also have to align with domestic versus international, Europe, our other trade associations and other entities. So it's never a dull moment and always a lot of work there to be done. So the topic we've all been waiting for, policy. So first of all, I wanted to start with what we're doing in the advanced recycling space. So in about 2018, we started efforts to have advanced recycling recognized in state legislation so that it would be recognized as manufacturing. And this would enable companies to come into a state and be able to obtain a permit and produce a facility. And in this legislation and lobbying efforts, we also wanted to recognize definitions of mass balance and various elements of advanced recycling. So in case you're wondering, the 25 states where this legislation has been passed are the lighter blue states, not the darker blue states. So we're really proud of those efforts because it is a really big step to get this recognized and towards the movement of circularity. We also have a federal policy called 5 Actions to accelerate a circular economy for plastic. So the first 2 are the most important right now and require a 30% by 2030 national recycled plastic standard, right? So recycled content. But you can't have that without more recycled content available as feedstock for a final product. So updating our laws to promote innovation and recycling through advanced recycling. So a lot of these elements are all connected, as you can see. Also wanted to touch on EPR, Extended Producer Responsibility. So we worked with our members to identify principles that we could all agree on of what effective EPR must include. Infrastructure build out, right? We need to have the infrastructure to accomplish this. Technological neutrality, right? Mechanical recycling, advanced recycling, it all has its place in these efforts and in circularity. Certification, right? I sound like a broken record up here. We need third-party certification and credibility. Mass balance recognition, important part of the puzzle. Special assessment and open material markets. EPR must not contain the following: material switching or production caps, right? Many of you may be familiar, we're in California, so it's fitting to mention SB 54, which would, starting in 2025, start to ban or require replacements of materials that do not meet the minimum 25% recycling rate in California, right? And this could lead to, excuse me, material switching or production caps. Material switching is an issue because we start then replacing certain materials that in the long run may not be better, environmentally speaking, and may cause other problems. So before we make the jump and switch out materials, we need to have this backed by facts and science. And also non-EPR provisions, so kind of a scope creep concern. All right, so quick show of hands, who here is familiar with the Global Plastics Agreement? Okay, a couple. So I'll give a really quick synopsis on what it is. The United Nations is working to bring together more than 170 plus nations to discuss a global plastics treaty to address the issue of plastics pollution around the world. As you can imagine, some of the countries and regions that are most susceptible to the plastics pollution issue may not be the ones who either have economic means to deal with the issue or maybe not have added to the issue. So, thank you very much. So it's not necessarily, we're trying to figure out in this global plastics treaty how we can all work together to address the issue. So with that, there are a series of meetings come together, negotiate parts of the treaty. There have been 5 of them. So far, there's been 4. The 5th and final one is in South Korea around Thanksgiving. And so we're hoping for a final agreement adoption in early 2025. So fingers crossed on that one. And I also wanted to mention, where does advanced recycling fit in that global plastics treaty? So governments should enable innovation and investment from the private sector. The agreement should be technology agnostic. I mentioned that before, but it should be open to mechanical, advanced, and other technologies. Increasing viable recycling options for more plastic types can generate more income for global informal waste management positions, right? So we're trying to address all elements of concern here. Last but not least, just bringing everything I just talked about, that was a lot of different items, everything in the kitchen sink here, but it's all part of the larger puzzle of circularity, right? Recycling is a piece of the larger circular economy, as I just mentioned. Advanced recycling and mechanical recycling are complementary, not substitutes for one another. We support policy backed by current scientific data, right? And then collaboration across industry sectors and organizations is a necessity. We really need to work together to achieve a more circular economy for plastics. We're not going to be able to do it alone. And with that, thank you very much.
Right, so as the next, thank you very much, Allie. The next presentation will be on advanced recycling, separating fact from fiction, and we have Jeff McMahon, Managing Director of Freepoint Ecosystems, with us for that presentation. Thank you, Jeff.
Good morning. As Steve said, my name is Jeff McMahon. I'm the Managing Director of Freepoint Ecosystems, and we are an advanced recycler. I'll show you a facility that we're building shortly here in the U.S. It's about to go online. But first, let me start off with who Freepoint is. So Freepoint Commodities Group is what we're a part of. We're that second box in red. So I run a company within Freepoint Commodities Group called Freepoint Ecosystems, and that's the advanced recycling business line of Freepoint. The other 3 divisions that we have are merchant energy trading, merchant finance and investments, and our retail energy solutions. So we're a company of collectively about 610 people, 16 countries around the world, $30 billion in annual revenues. So let me talk a little bit about Freepoint Ecosystems, which is what I represent. What we're targeting, really any advanced recycler is targeting this, we're targeting the hard-to-recycle plastics, using advanced recycling technology to convert it into a feedstock for the petrochemical companies to make new plastic from, which displaces the production of oil and natural gas. 90% of most waste plastic either ends up burned or buried, either ends up in an incinerator or waste to energy, or it ends up in a landfill. And one of the things we're trying to target here is divert plastic from those end uses to keep plastic out of landfills, as well as reduce greenhouse gases in the making of new plastic. So why we're here is really kind of the world is on an unsustainable trajectory right now. If you look at this top left slide, that's the projection of plastic consumption increasing over the next 30 years. It's supposed to more than double current consumption today. So in order for the plastic industry to keep up with that demand, the next chart on the right is what the oil consumption is to meet that demand. Right now, the petrochemical industry consumes about 9 million barrels a day of oil and oil-related products in order to produce the plastic. If we go on that trajectory of doubling by 2050, the oil production to meet that would also almost have to double. So we're sitting in a place where plastic demand is increasing, oil production to keep up with it is projected to increase, and yet our recycling rates are declining, certainly in the US. So we're looking at a problem that is essentially has to be solved. It's unsustainable. So our vision is really a circular plastic economy, which is, I think, a lot of the people in our space are in that road. So the current linear version of a plastic life cycle is it gets produced, some sort of crude oil or natural gas product gets produced, it goes to a refinery, gets converted to a lighter end product, it gets then to a petrochemical company, he'll turn it into a monomer, and then ultimately a polymer, which is the plastic you're used to seeing. At end of life, it either ends up, most of it will end up in either an incineration, waste to energy facility, or a landfill. So our goal is to knock out the first piece of this equation, or at least reduce it, substitute recycled oil for produced crude oil or natural gas, and then in end of life, keep it out of landfills and incineration. So how do we do that? We do it through an advanced recycling facility, which takes that waste plastic at end of life, diverts it from the landfill, puts it back through a pyrolysis process or an advanced recycling process, and converts it into a substitute for fossil fuel-based feedstocks. And this is a chart, this is that earlier chart that comes from what oil production would have to do to keep up with that plastic demand that the industry's forecasting. If advanced recycling takes hold as we hope, that combined with mechanical recycling could bend the curve here from that almost 20 million barrel a day consumption to meet that plastic demand of oil to something close to what it is today. And that's really the goal, keep oil in the ground. I'm going to give you just a 90-second video on advanced recycling, if I can do this right. Let's see if this works.
Some things don't go together. Stripes and plaids. Cats and coyotes. 3 a.m. and good decisions. Plastics and the earth. But let's face it, the things we do, the way we live our lives, our society depends on plastics. But what if there was a way to recycle virtually all of the plastics that we use? I know. You've heard it before, right? Sounds more 80s than a bad hairband. So instead of just recycling those water bottles and milk jugs, what if there was a way to return almost all plastics to their original form? Take them from the grave to the cradle. It's called advanced recycling, or pyrolysis. In technical terms, it's a chemical recycling process that converts end-of-life plastics back into a petrochemical feedstock, producing new plastic products using a fraction of the fossil fuels needed to produce traditional plastic. In non-technical terms, it's a game-changing innovation for the recycling industry, like reversing the rotation of the Earth. And best of all, it's a reality. Imagine a way to divert almost all plastic waste from anywhere, landfills, waterways, even the blue bins, to its own facilities. A company that actually wants your plastic trash. Not in your backyard? Okay, how about in our front yard? Please. Look, we'd love it if people use less plastic. And if they can't use less, they should reuse or recycle. But these plans have limitations. Despite our best efforts, 90% of waste plastics end up in the trash. It's time for innovation to drive a better solution. Earth is worth it. Life is worth it. Our kids are worth it. And then maybe, just maybe, we could pull our striped pants and plaid shirts out of mothballs and party it up with the cats and coyotes until 3 a.m. Now, isn't that a planet worth living on? Freepoint, using innovation to reshape the way we use, reuse, and recycle plastic.
Okay, so apologies for the commercial. But let me, I'm going to get into the fact versus fiction on advanced recycling in a minute, because there's a lot of noise in the system, mostly coming from NGOs who are just kind of opposed to plastic generally. But I do think it's worth explaining the difference between mechanical recycling and advanced recycling if you're not familiar with it. So mechanical recycling is generally what happens today at your curbside pickup. This material, the waste plastic, is mechanically ground in through shredders and grinders into a flake type of resin. And then that flake is then used by converters to mold into new containers. You know, it's a pretty simple process. The finished product, though, is not the same as a container made from prime resins that come from fossil fuels today. And as a result of that, the applications of it are somewhat limited as well. It's typically not able to be used in food applications or medical applications. And you can only do this a few times through mechanical recycling before the flake is not being able to be formed back into a new container. And then lastly, but it's probably the most important to us, is only about 20% of all plastic produced can be recycled this way. So 80% of the plastic that you're used to seeing can't even be recycled through mechanical recycling. So hence, we move to advanced recycling. That's what we do. This chemically converts the waste plastic back into its original hydrocarbon form. And I'll talk about that in a second. But so what you end up with is an oil product that the petrochemical companies can use to make new plastic that's completely indistinguishable from plastic made from a fossil fuel product. So it's an identical product. It can be recycled as many times as it wants. There's no limit to it. And it picks up that 80% of plastic that currently can't be recycled mechanically. And then I'll show you in a second, there's a roughly 30 to 90% reduction in greenhouse gases making plastic with this recycled oil that comes from advanced recycling versus something from crude oil. So let me get to the punchline here. I want to address probably the top 4 or 5 items that we hear in the marketplace, which is typically misinformation or not understanding of what the process is. And the first one is advanced recycling doesn't work. And that's just factually incorrect. This is a very simple process. If you think about plastic, it's about 95% hydrocarbons. And there's 5% additives that are added depending on what the application is. There's some layers for like a Lay's potato chip bag that keeps the product fresh. That's typically not a hydrocarbon product. So what pyrolysis does through advanced recycling is it heats up the plastic. It's key to this. It doesn't combust it. It heats it up in an oxygen-free environment and essentially turns those hydrocarbons back into a gas. And then that gas is put into a cooling tower and liquids are knocked out of it, basically. That's the process. It's very simple. It's been around for 60, 70 years. What's just not around is scale today. Next thing you hear about is, well, I'll say it more at a positive standpoint. Advanced recycling is currently scaling globally. Google estimates in order to meet the demand for the recycled oil product by the petrochemical industry, over $500 billion of new infrastructure needs to be built in the advanced or chemical recycling marketplace. This chart shows you worldwide announced projects to date. This is over 3 million tons a year of advanced recycling infrastructure that's been announced to be implemented in the world. That translates into a little over $10 billion of investment that have been announced today. And it's not just in Europe or elsewhere. These are the announced U.S. projects that are slated for the U.S. This is a pretty small slide, but Freepoint's there in Ohio. I'll show you that in a second. That's our premier advanced recycling facility. When it's finished, it'll be the largest recycling facility in the world that has circular plastic to it. And then in Arizona, you'll see that was our second facility that's been announced as well. We're probably going to announce 2 more in the next 3 months. So the scaling of advanced recycling is occurring. And this is our project just outside of Columbus, Ohio. We reached mechanical completion about a month ago. This is a 90,000 KTA facility. It should get commissioned over the next 4 to 6 weeks. And we'll be loading rail cars of this recycled oil to ship to our petrochemical customers in the Gulf Coast. So the notion that advanced recycling is not scaling is just not right. I mean, this is a $250 million facility, and there are billions of dollars worth of facilities in some sort of development right now. Ali alluded to this as well. Advanced recycling can bend that recycling curve I showed you. You know, recycling rates are declining generally in the U.S. Oops, I think I'm in the wrong. Well, sorry, I missed one. Yeah, sorry. Let's talk about certification. You hear a lot of noise about advanced recycling is just another way to greenwash a product, and it's just inaccurate. The process does work. It converts the material back to an oil-based product from waste. And more importantly, the certification process is very, very rigorous. The group that certifies most chemical recyclers is the ISCC Plus out of Europe. We've been through 3 audits in 3 years. They come to every person who has certification and make sure that that handoff from waste plastic in to oil to the petchem to resins to the converter to a container to the consumer products company. Each one of those handoff has to be between certified people who are audited by the ISCC. So the certification is real, and it is not a greenwashing concept. We can bend the curve on the recycling side. These are all the plastic numbers you're used to seeing. Advanced recycling is the green, so we can pretty much recycle back to the original hydrocarbon form just about every type of plastic but PET and PVC. And on the PET side, that goes to the mechanical recycling market today. It's well established, it works. Curbside pickups is successful, so that's already handled. So really the only piece between mechanical and advanced recycling that's not covered is PVC. And there's a lot of technologies right now underway to try and find a way to recycle that. Just talk about our supply sources. There's really 3 main areas we look for. Post-industrial material, which comes from, factory floor trimmings, those type of things. Recycling industry, a lot of waste comes out of the MRFs, plastic waste. Roughly 30 to 35% of what goes of plastic that goes in the front of a MRF comes out the back end as residue. These are mostly your films and heavy rigids, toys, and things like that. So there's a lot of material that we can get from MRFs and mechanical recyclers that is residue for them. And then the last one is municipal solid waste supplies. We are working with various landfill owners where we can divert the plastic before it gets to the to landfill. Another kind of myth here is advanced recycling is bad for the environment, which is just incorrect. As I said, it reduces greenhouse gas emissions. I'll explain that in a second. It diverts material from landfills, which creates, if it's in the landfill, it creates microplastics in the leachate. And it's a circular product. It really does keep the material circular, which displaces new oil production, is what everyone wants to do right now, is keep carbon in the ground. This is probably the biggest one we hear from the NGOs who are against advanced recycling, and that's advanced recycling and incineration are the same thing. And let me just walk through them a little bit because they're radically different. Incineration actually burns waste plastic. It combusts the hydrocarbon to generate heat for, typically in a waste-to-energy facility, it's making steam to make electricity. So it's actually combusting the hydrocarbons like internal combustion engine would combust it. That results in CO2 creation, and it's a non-circular process, right? It takes end-of-life plastic and converts it to electricity, but then that plastic is never reused. So as a result, the petrochemical industry has to produce new plastic to make, or new oil to make new plastic. Advanced recycling does something quite different. We heat the waste, as I said, without oxygen to prevent combustion of that material. And then we bring that through a chilling tower to convert it back to a liquid product so we can displace oil production. It's a much smaller footprint on CO2. There is a thermal process here. You need to heat this up. But the amount of CO2 emissions is much lower than it would be in the traditional way of making plastic. It's completely circular, and it leaves oil and carbon ultimately in the ground. So here are some fun facts about the emissions itself. Advanced recycling does emit fewer greenhouse gases than making a new plastic, which is that left-hand column. It's lower than if you went and incinerate those two. If you really think about these charts, those first two should be combined. If you're making new plastic and at end of life it gets incinerated, that's the CO2 footprint that makes, versus chemical recycling, mechanical recycling, and then another chemical recycling view. And the difference between those two graphs is really what would have happened with end of life. If the plastic was otherwise destined to a landfill, good news about plastic, it is a good carbon store. If it otherwise were heading to the landfill, that's the reduction in greenhouse gases on that first green one on the left. If it was going to incineration, then you're saving all the incineration CO2 as well. So we're somewhere in the range between 30 and 95%, depending on what the end-of-life plastic was. And as Alex said earlier, don't take our word for it, take the scientist's word for it. One thing you'll see when NGOs come out, they typically have no studies backing up their concerns about chemical recycling. I'm not going to go through all these, but there are countless independent, objective studies that support the fact that advanced recycling is a reduction in greenhouse gases when compared to the conventional alternative. And I'll just leave you with these couple things here. You know, the takeaways for advanced recycling. It leaves carbon in the ground by reducing new oil production, recycles almost 80% of plastic that is currently not recyclable via mechanical recycling. It's proven. It's been proven for decades. It's just now scaling. And so we need to let that process work out over the next 5 or 10 years. It makes a plastic product that's every bit as good as made from fossil fuels, which is very attractive to the consumer products companies. They spend decades and hundreds of millions of dollars getting their packaging right, so their product is fresh or it doesn't leak or whatever they're looking for. Having an alternative to that is very, very important. Creates thousands of jobs worldwide. That facility you saw for us in Ohio employs 105 people, and then each one of these facilities would be similar. And it's a necessary bridge. I mean, we can't get off plastics tomorrow. I don't think anyone thinks that's possible. So maybe there is a zero plastic world in the future, but it's going to take decades to get to. So this process at least keeps us on the road to circularity and reduces the greenhouse gas emissions during the process. Thank you.
Excellent. Thank you very much, Jeff. Very informative. And it's always good, as we say, to have earlier the scientists backing up the programs that we're doing. You know, there's a study we waited for many years to come out and then be redeveloped on the comparative emissions of greenhouse gas from landfills and those from traditional incineration and waste energy. And that report was very compelling and very revealing and very informative for folks. And it's a good approach to take when we're looking at the further development of the lower emission thermal technologies that a lot of us are here talking about, a lot of you are here talking about today. So thank you very much. And again, we like to listen to our scientists, especially since our NGOs, they encourage us to listen to scientists. It's just a matter of which ones collaboratively we all work with and listen to, and there's value on all sides. So I want to wrap up today's session, this morning's last session, with decentralized developments of chemical recycling, a strategic approach to addressing plastic waste feedstock challenges. Brian Bauer, CEO and co-founder of Resynergi, is going to join us. Thanks.
Thank you, Jeff. I think that was the best overview of advanced recycling I've ever seen, and it's a great video too. I'm so happy to be back here. Thank you. It's been 2 years. We were doing an early pilot back then. There's a lot to report. Basically, what Resynergi does is advanced recycling. We do small scale as well as very large scale, so we're working on some big projects internationally and more small scale domestically. We are one of the only guys who does this in California. We definitely see a path to doing it and helping the situation here while we're at it. So what's happened since 2 years ago that I presented is we finished a 2-year pilot. We're closed a Series B round of VC funding led largely by Lummus Technology, so we have a really tight bond with them and helping to go to manufacturing. We shipped our first tanker and expecting to ship a lot more. So when we talk fact versus fiction, I sort of thought we'd talk about who's shipping oil, not just infrastructure. It's a big thing. Only a few people are actually shipping oil. And we want to put ourselves in that camp, and I'll show you a map of where we're going to go, our targets all over the country. So without, I do want to say we also, team-wise, Lummus is a key technology partner. We now have our senior team is Shell and BP, former CFOs. Those are probably the most responsible of the larger companies that for doing chemical recycling and doing green things. Anyway, the team is far different, the company is far different, and I'm super excited to present. So what we do is we use microwave technology. So our process is fast pyrolysis, so we go about 250 times faster depending on which system you're looking at. A single speck of plastic will go through our system in about 30 seconds. Others, it's half an hour or hours in very big reactors. Our reactors are very small, and we are just repeating that reactor over and over again, sort of like a server farm or battery farm type of thing. So with that, we can be super compact, modular, to any scale again. We have very high quality oil, and it ranges between 20 and 68% greenhouse gas reduction. So lots and lots of data in our 2-year pilot. And it's just 2, 4, 5, and in the future 6. So we're very focused on just 2, 4, 5. We have great feedstock agreements. Even though there's not diversion consideration for films, for example, in California, we're doing it. It's economic. We will show the rest of the world that we can recycle plastics, actual films, and so we'll get Cal Recycled to make it a diversionable. That's not a word. Diversionable plastic. So what do we do with that compact structure and that microwave? We do a decentralized approach. Again, we can put an entire plant on a skid. So what we make is straight pie oil. In the early days, we made diesel fuel and shipping fuel and so forth. That's an extra step. The world convinced us just do base pie oil because there's a huge demand for it. There's a great index in Europe now for pie oil. So we really support this industry. So what we do is we just make a basic pie oil skid that does 5 tons per day. It fits on the back of a truck and can be deployed very quickly. So that model is manufacturing centrally, but deploying decentrally. So it's actually flipping the world upside down. Most people are actually manufacturing on site. They're building their plants on site and doing a lot of engineering customized per site. We don't do that. We do the manufacturing of the plant centralized like you would do a car and so forth for the best economics, and then deploying it with a minimal amount of work on site. So It allows us for startup costs at $5 million roughly to do one skid with everything around it to turn up a site. And we can, if you go into an existing location that's industrial zone and plenty of room, you can scale that to many, many, many units. So if we wanted to go and have a footprint all over the US and show the world advanced recycling can be done, decentralized is a very, very fast way of doing it, and it's very low risk. So a risk chart here, real simple, little glitch there, but we basically take our system and go where the plastic is. So the real expensive, difficult part of this whole thing is the logistics is moving plastic all over the place, moving plastic to centralized locations. We take our system and go where the smart hubs are. So there's still some spoken hub activity, but the reality is we can go right to where the plastic is and process it there, and then ship the oil via rail lines and so forth. So it's a highly efficient way to operate. Now we can turn up, when we talk about permitting, we can go where the buildings are already permitted or the infrastructure is already permitted and turn up very quickly. And we're working on templated permitting processes. That's why I love what ACC is doing, that project you're working on. We might actually join now. So that's very interesting, because if somebody's asked what are the biggest challenges, it's permitting, and then it's getting staff and automating your system really, really well, so so almost anybody can operate and it's very smooth. So it's also very safe. The initial investment, I talked about the initial investment, but the small reactors, because we're such fast pyrolysis and the reactors are so small, there's almost no fuel, call it fuel, the plastic inside, for if there's like a meltdown, it's a bad example, but if there was anything that goes wrong with the reactors, there's not much that can go wrong, because there's just only less than 10 kilograms or a few kilograms of plastic in our reactor at any one time. Very different than a centralized type model. We talk about environmental justice. We will hire, wherever we go, to hire between 20 and 40 employees. The CO2 carbon footprints is equivalent about 2 semi-trucks driving down the road. It's very, very small. So we can go into some of these existing neighborhoods that are already zoned for this, have a small impact, but give a nominal number of jobs. It's going to be very positive. The other thing that's elephant in the room when we talk about waste conversion is actually keeping these systems up straight line many, many days in a row. We can do that much better with redundant reactors, so we can rotate maintenance on the reactors and keep the systems up all the time. That's a key thing. And I mentioned before the steady, reliable quality of the skids, because we're manufacturing those centrally in a high quality way, and then just deploying in the field, making it simple to deploy in the field. So there is one really key, let me talk about systems here and operators, but this is a typical site. This is very similar to what we're building right now in Roanoke Park. So we have one site in Santa Rosa that went really well with the pilot, shipping tankers out of there. Second site is 20 to 40 tons per day with 4 modules initially. So the modules just drop in. There's a utility skid that has chillers, air compressors, those type of things that are standard off the shelf. And then the far left there is the generators, co-generator. So we're working with Mainspring, which is a linear, cross-linear generator. It's a 45% efficient generator, very low CO2, and it's got a scrubber on its back end to make it really clean, cleaner than the flare, which is actually pretty decent. So that's a site. It's only 200 by 100 feet. That's very small for these kinds of projects. We don't need acres, but we like Imperial Valley anyway. So we're looking to go in a lot of, but flexibility is really good for this. Maybe we need high ceilings, 25, 30 feet, but other than that, we can go anywhere. So we'll talk a little bit more about the second thing other than permitting that's a big challenge is making the system super automated and very, very friendly to operators that don't have that much skill. The number one cost for a profitable site is labor, so it's so important to be efficient with labor. So we've teamed with Lummus Digital, which is it's a new joint venture that Lummus has, and it's using a lot of machine learning, AI techniques, but the most core thing that the industry is used to is monitoring, creating a digital twin first. And so we're starting to phase this in where we monitor all the different sites. And you can imagine the database of machine learning that, with all of this, all these different sites. But first monitoring and then, doing predictive analytics over time. And so we'll know, and we can sense when, even though we're maintaining rotating reactors, we can sense when a reactor should come down prematurely in order to keep it up. So again, uptime is huge, and employee labor use is super key. So this will help that a ton. So showing here what we have in Roanoke Park. This is a couple months old. We brought the new reactor in. This is turning up and getting commissioned next week. Again, this is our second site. And where we're going is we teamed with Alliance to End Plastic Waste. A lot of the same ACC members are there. With Plug and Play in Silicon Valley. We were pulled in because we were microwave and decentralized is a very new approach to what Houston's doing. We love Houston. We team with Houston very closely, but we think more outside the box. So what we are aiming for is 350 MRFs in the US. Whatever makes sense based on heat mapping, cost of labor, cost of fuel, cost of the 25 states that have that are very friendly to advanced recycling, starting in California, because if we can do it here, we can do it anywhere. So those are our targets, not all 350, but over time, the fastest way to show the world at many sites they're shipping actual tankers of oil is decentralized. So we did great teaming with Lummus. Now we're looking for investing deployment partners. People will help invest and help get the project financing for multiple sites, and they are really, really experienced in deploying refineries and that type of thing. So we're working real closely with them to actually do major, large projects internationally. So small, medium in the U.S. and much larger projects internationally. So we're not doing projects with all those companies, but those are the members of AEPW, and 2 or 3 of those we've got great offtake agreements with. And plan to move forward. So with that, I don't even get the 5-minute warning. I'm used to doing those pitch fests where it's like 7 minutes long and you got to fly through it. So I think that's it. This is basically the system, and it can deploy in so many ways. I'm happy to take questions. Yeah.
It's so exciting to see Ryan come back, 2 years later and report on the progress. When I get forced to watch that Shark Tank show at home, every once in a while you see someone who was on there a few years back, and they're with these great industries. So it's always good to see what some of the places that we go, some of the things that we encounter, to see the success later on, especially in our industry. So that's exciting. I do like the Shark Tank. I don't have to be forced to watch it. I just hate it when they say no to people. I'm like a softie. I just like, give everybody some money. You guys have money. Just give them all a shot and let them figure it out. But it's fun stuff, and that's our industry. Financing is a big issue. So like to have some questions now. We have plenty of time left for questions. This is a great panel in monitoring their own time. I didn't have a lot to do, so that was great. Norbert has a microphone. We have one right there.
Thank you very much. For Freepoint, what percentage of the waste that you bring in do you reject? So what's the percentage of the waste stream for one of your advanced recycling facilities? How much waste would you have left over that could go to some other process?
Yeah, it's a good question. It really depends on who the supplier is. If it's a MRF, it's probably 30% material that's not plastic. It's coming to us. We're either, if it's recyclable material, recyclable material, like let's say it's PET plastic, we'll capture that and sell it to the mechanical recycling market. But if it's fiber like carpets and things like that, that'll go to a landfill. So we try to minimize how much non-recyclable plastic we bring in, because otherwise we're paying to move trash. So it hurts our economics. But there's just so little sorting done on this residual material that in order to get that material out, you're going to have to do another sort. So you're going to end up with a waste product.
Thank
Oh, right over here.
Yeah. This question is for Brian. Hey, Brian. So in mass balance approaches, one of the hardest hit things is actually looking at energy consumption with sorting out waste in your MRF systems. How does your system, which is a smaller scale system, apply to that, where you can take maybe different feedstocks with different units?
I love that question combined with the one right before. We looked at what's called Reject Mountain from Recology. I know there's they'll have a whole bunch of plastic and then shoes and other things that shouldn't go in what was supposed to, it was a collected blue bin thing. And it was an absolute nightmare to try to sort through that. So since then, we have contracts with them and others in the Bay Area that they sort it, and because it's so expensive to landfill in California, they actually are happy to pay us in between that price and what they give us, and they pre-sort it for us. So we get lots of, we love dirty film. So that film, people say that you can recycle film, and it is recycled. The only thing that's been recycled is really, really clean film to date. And so 1/15 of the film that's recycled today is that clean film. So we're really happy right now. We're just going to keep close to all the MRFs, and hopefully for a long time they'll do the sorting for us. We have a long-term plan with a lot of the sorting people and robotics people and so forth to do more of that, like secondary MRFs and that type of thing. But we're watching real carefully what secondary MRFs do to the entire business case. There's going to be a challenge. Yeah. Thanks.
What do you do with your aluminum?
Aluminum?
Like the lining of a potato chip bag and a top of a yogurt container?
Which one do you want it? So yeah, for us, we have a nice system. So a lot of caps might have some Mylar film in it. If we don't have too many of the bags, we're fine with it. A company, Envol, give them a little pitch. They focus just on those bags that are multi-layer. But yeah, we'll get a good amount of those metals sorted in the bottom of our charge. Just the way our system works does that well.
So once again, on your modular-based systems, if you are looking at separating out the different types of waste, and yes, going to fuel products, you have to have a very refined feedstock going in. But what if you were to separate some of the syngas coming out and take that to electricity that is managing your system while the rest is going to a fuel product?
Yeah, so there's a nice break. We get about 23% on average of non-condensable gases coming out of our system. We use that, as I mentioned, the mainspring generator, the co-generator, because that's 45% efficient. That is just about exactly what we need to run our system. So if you look at a black box, there is zero energy being used to power our system, and 73% is pie oil as product. So there's some studies, you got to read these things. Fact, fiction, again, like NREL put out a white paper that says pyrolysis is really energy intensive, but if you draw a box around it, say what's coming in, it's zero in, and it's 72% mass balance out.
Brian hit on the point I was going to make. And Allie, you showed it. Jeff, you talked about it. There's tons of good data, but then there's tons of, I'm going to say, sound terrible, ignorant people that aren't getting that data. So there's this massive gap, and some of us talked about it last night, where some states say, oh, mechanical only, the energy usage is much lower, you have to go mechanical. But oh, by the way, Jeff showed it can only take 20%, so I get this 80% laying over here. So it might be a rhetorical question, but how do the people in this room or the industry kind of band together behind the data that we all have to change the rhetoric, which is going to help with permitting, I think. It's going to help with regulations backing off, and I think it's going to move the whole industry. And maybe this is the silver bullet question, but I mean, any thoughts on that?
Yeah, sorry, I got excited for that one. Thank you for your question. Yeah, but I would say one of the components is knowing how to communicate this scientific data and this highly complex information and simplify and boil it down without losing the validity of the scientific information. And it is a sweet spot, and it is very difficult to do. How do you get the information from the scientists and the engineers to policymakers and legislators? So the reason I got excited is a lot of what I've been doing over the past couple years since I joined ACC is taking different scientific reports and pulling out key information, key comparisons, and turning them into FAQs or Q&As that our staff and our membership can use. So when a report comes up, what are the key points from it? What is truth? What is myth? What is a possibility? So we can understand that more. It is a long road, and it's not that my Q&As or my FAQs that I make are going to be the silver bullet, of course. I have to be honest with myself, right? But they are a step in the right direction for, again, connecting the good science and information to the people who need to hear it. And one of the other elements is the NREL report that was mentioned by Brian. It was funny, I was thinking about that report before you mentioned it. And, again, it showed really different findings about pyrolysis compared to that Argonne National Lab study that we worked on. And so I went through the NREL report and pulled out information of what's the difference between our life cycle assessment and their key findings. And they used a completely different process for upgrading the byproducts into new polyethylene. So they were using a very different approach in comparing more or less apples to water bottles. And it's like, okay, well, you can't compare our two reports, and this is why the findings are different. So getting that across and being able to communicate that as well, to say, like, we're not saying the report is wrong, it's scientifically correct and valid, but it's different from ours because of this. And that's really important to do as well.
Maybe I'll just add, it's hard. It's the short answer. It's a lot easier if you're on the opposite side of this equation to say, well, it's bad. Plastic is bad, carbon is bad. And then to defend that, you bring out these very complex scientific studies. And ironically, the former is easier to deal with than the latter. So I think it's going to take a lot. We need policy help. It's got to be national. New Jersey has deemed advanced recycling not to be recycling. It's not going to be considered recycling. It's one of those states that I think Allie had up earlier. And so you think this through. How does this work? So we make a recycled oil in Ohio. We send it to Shell, who turns it into a plastic resin, ultimately a shampoo bottle from Procter & Gamble, and Procter & Gamble fills it up. Can they sell that in New Jersey as a recycled product, but they can sell it across the river in New York? I mean, there's got to be some logic and kind of playing field that gets established here. But it's early days. But I think policy. We've got to be focused on policy help, because the industry is not going to be able to do it by itself, especially when you have 50 different jurisdictions to have to permit it.
I just want to say I loved your video. But there could be a little more advanced one for the next step, but it was great.
I understand both of you are producing an oil that you send to the oil company. What is the process through the refinery that gets it back to the plastic?
If I understand the question, what does the refinery do with our oil? Is that the question?
Right.
Yeah. So there's really two ways you're making plastic, right? You're either making it from an oil-based product or a natural gas-based product. If it's an oil-based product, in the conventional way, it's taking crude oil, refines it into the, how refineries work, it splits it into different, basically, densities of material, the lightest of which is naphtha, and that's what goes to a petrochemical company to make plastic from. All we do is we replace that crude oil with this recycled oil, and so it just goes through the refinery like a crude oil would go through.
So it still goes through the refinery process?
Yeah, it still has to be separated into the lights from heavies, and because they have to crack this into these monomers and then to make the polymer out of.
So it still has the stacks and it's blowing out whatever it flows out of.
Yeah, I mean the refinery is still going to have its emissions, but what you're eliminating here is the whole upstream oil and gas production piece of the segment, as well as landfill diversion or incineration diversion on the back end. So it's materially, if you look total life cycles start to finish, it is anywhere from 30 to 90+% less greenhouse gases making plastic that way.
But it's not, when a mass balance, it's not physically segregated, so it has to be mass balance. So plastic producer, my company can say, yes, we got that, but in theory, what you guys make could have been combusted as a fuel too, right? And that's where the mass balance has to come in.
Right, and that's going to be coming out of the refinery more so than out of the advanced recycling facility. But you're right, if you put 100 units into a refinery of recycled oil, and that refinery took 1,000 units in total, you can allocate those 100 units to 100% to your naphtha product in that example.
To a product that's a durable plastic good
Right, exactly.
versus a fuel, because some people then argue that too, that you're combusting it and that's not circular. Okay.
Just a friendly reminder to please use the mic as you ask your questions. It's not so much that we cannot hear you, but we record the session for future references. You'll be next.
Tom Hintz-Seahold. I have a question. How much, you're saying you eliminate the upstream virgin oil and gas production, but I mean, how much is lost in the process? And don't you need some makeup? I mean, you can't keep recycling it forever. I mean, you're going to lose the aromatics. You're going to lose the lighter eventually. I mean, it's a lossy process. So, I mean, what's the percentage? I mean, you're still going to need oil to come out of the ground. Yes?
Yes. I mean, if you're fast forwarding to can we make the amount of plastic we intend to make in 2050 without any upstream oil and gas production? No, I don't think, at least not in today's technology, because you're right, you do have a yield loss coming with plastic in versus oil out. But the amount of reduction in production is really what we're targeting here. And like I said, it's kind of on a bridge to maybe there is a plastic-free environment in the future. We don't know, but the first thing we got to do is stop the craziness we're on right now, which is we're increasing oil and gas production, we're increasing plastic consumption, and we're decreasing recycling. That's just not sustainable.
I was gonna say, yeah, when there's also some value to collecting the plastic all over the world, it makes a huge difference. So a lot of what advanced recycling does is just cleans up the world.
I wholeheartedly applaud the direction you guys are going in. I have a completely self-serving question here, but so I'm with Sierra Energy, and we do gasification. And so a lot of the discussions we've had with people is that we take the whole waste stream, 100%, turn it into synthesis gas, and then through FT pathway you can make virgin plastic. So you take the whole waste stream, not just the narrow segment. But a lot of the folks we've been talking about saying that's more difficult, and so why not have a gasifier sit behind what you're doing and allow you to become 100% recycling and use the synthesis gas to run your processes and things like that. But at least that way you can show circularity of everything can go through and you end up with 100%. But I mean, have you all considered anything like that?
Yeah, I just want to say some of the people who do PET bottles around the world, they have tons of like films and other things that they want to process. And they have a way of dealing with PET So I'm sure you're doing the same thing, is you want to team right next door to a guy who does PET, or a guy who, there are some ways of recycling PVC a bit. We don't want to touch it, but it's, yeah, we've talked about having those partners, but MSW, yeah, why not?
Because gas-fire could take all of that easily. I am going to do what I can, start flinging business cards at people before we're done with this.
Any other questions? That's great.